We usually approach intelligence as a biological capacity that scales with brain size, a property an organism either possesses or lacks. Yet a bee can solve highly complex spatial puzzles with a brain the size of a sesame seed. Entire forests coordinate nutrient sharing and drought responses through underground networks, operating without any centralized brain at all. These examples suggest that intelligence functions as something other than a quantifiable piece of hardware or a stored essence. At its base layer, the universe operates as a series of system dynamics governed by strict physical constraints and the immediate availability of energy. Rocks, trees, and humans all inhabit this same environment. They simply utilize different mechanisms to persist within the specific constraints of their local systems. Intelligence identifies the specific operational actions a system takes to navigate the rules of physics and avoid collapse. Inanimate matter operates through pure physics, reacting to environmental forces with perfect, blind consistency. This boulder follows the path of least action. Without needing an external energy source to maintain its state, it cannot choose a different trajectory. A biological cell, however, must actively acquire energy to persist. It faces a survival requirement without having the centralized control necessary to seek out resources. Life solves this through distributed constraint navigation. By spreading risk across a vast network, the system bypasses local failure. DNA acts as the long-tail memory kernel, storing successful bypass routes from previous generations, so the environment can prune the failures. Biological systems persist by distributing their trials so widely that the core pattern survives the loss of individual nodes. This distribution strategy reaches its limit when energy sources are rare or require a nonlinear path to reach. Blindly running every physical option becomes too energetically expensive for the system to survive. Intelligence emerges as an approximation of constraint navigation. It allows an organism to stop guessing with its entire population and start testing paths through targeted internal modeling. Systems develop recursive feedback loops, often regulated by dopamine or stress signals, to map reward gradients and reinforce the most efficient trajectories. A frog's brain has learned that this specific sequence of movements yields an energy reward. The internal feedback loop reinforces that action, allowing the frog to approximate the fly's path with increasing precision. The brain serves as an engine for this approximation, navigating environmental constraints on behalf of a body that cannot compute the full complexity of its surroundings. Intelligence is the biological process of using these feedback loops to navigate a nonlinear environment more efficiently than trial and error. While intelligence allows for faster navigation, human cognition introduces a different operational capacity. This capacity is frequently confused with more intelligence, as if consciousness were simply a higher volume of feedback loops running in the same direction. Consciousness represents the shift to constraint adaptation. This occurs when the recursive feedback loop begins to monitor the navigation process itself. The system gains a topological layout of its own constraints, allowing it to see why its previous models failed. Instead of merely reacting to a dead end, the system recarves the space. It uses its operational awareness to identify the limiting constraint and modify its own behavior to bypass the barrier entirely. This shift allows an organism to stop passively navigating the constraints the universe provides and begin actively reshaping them to create a new path of least action. Within this framework, consciousness is the process that operationalizes constraint adaptation, the ability to modify the rules of interaction when a system hits a structural limit. This mechanism moves beyond the individual. It explains why humans are born without innate speech, yet develop the most complex coordination protocols in the known world. We utilize coupled consciousness, a process where we connect our internal adaptations to the adaptive discoveries of others to stabilize our collective environment. Language serves as the medium for this coupling, a form of remote constraint shaping. It is the bilateral, repeatable transfer of information used to alter another person's understanding of their environment. By speaking, we share the data of a failure and the logic of an adaptation. This allows a second person to reshape their navigation of a constraint without having to physically encounter the same risk. Our technology and social structures are the compounded results of billions of these transfers, where adapted constraints are shared and stabilized across generations. Consciousness functions as a shared dynamic network, allowing us to collectively adapt the constraint fields we inhabit.